All right, it's 11:02. Why don't we get started? Thank you everyone for coming out in the snowy weather and taking time out of your busy day and busy morning to by Kathryn Monacelli as part of the Finger Lakes Invasive Species webinar series. Kathryn Monacelli has been with the Finger Lakes Institute in various aquatic roles since 2016. She was the water chestnut project manager, and now she's the hydrilla project manager. And both roles have been significantly on the water, doing surveys for plants and aquatic organisms, and so we're very lucky to have her. So I'll turn it right over to her. My name is Hillary Mosher. I'm the coordinator for the Finger Lakes Prism. This is being recorded. This will be available on the Finger Lakes Prism website, and I will post a link to the chat. Please, if you have questions, put them in the chat box, and we will address them as appropriate. So take it away, Kate.
Awesome, thanks. There we go. So yeah, I wanted to provide an overview of all of these wonderful plant sampling that we've been able to do since I came to FLI in 2016. First, well, why do we care? Well, it's not all just seaweed down there. So macrophytes, or the aquatic plants, provide habitat for invertebrates. They also provide spawning habitat for fish. The fish also eat the invertebrates, so it's the home for fish food. They provide other wildlife food source and habitat for things like turtles and waterfowl. They produce dissolved oxygen, which is also important for all of the wildlife associated. They also stabilize sediments, so the water won't be nearly as turbid if there's plants and roots to help hold the dirt down. And they, depending on the species, it can also be an indicator for the water body health. And we're on the lookout for our invasive aquatic species because we don't want our water bodies to turn into this. So the picture on the top here is of water chestnut, and it looks like you could just walk across that creek. The bottom two pictures on this screen are hydrilla and starry stonewort. And you can see how they would sprawl out across the sediment and outcompete and shade out any other aquatic plant that we might want there. And so our survey programs try to detect these species in particular, but also other invasive aquatics before they can get to this point. So I'm sure plenty of people have seen the invasion curve, but just in case anybody hasn't, this shows the progression of invasive species populations over time. So when there's small numbers, or very small populations, it takes fewer resources to manage them. And there's possibility of eradicating those populations. As time goes on, the populations can grow exponentially, and it becomes much more costly in terms of money, time, resources to try to control those populations. And so we absolutely don't want our high priority invasives getting to this point. We want to find them as soon as we can. So since 2016, our survey programs primarily use the rake toss method. In the photos here, you can see the gentleman holding a garden rake that has well, two garden rake heads that are zip tied together. When that's attached to a rope, you can throw it into the water, ensuring that the rope goes out away from the boat. so that when the rake drops onto the bottom of the water body, you drag the rake back to you, it pulls up the plants as it comes, and then you can identify what species are there and give the density and abundance value. So are there lots of plants or are there very few plants? This is how we typically classify the rake toss densities. So ranging from 0, just no plants. One stem or one leaf might be trace. A handful of plants on the rake would be sparse. Covering the tines of the rake would be medium. And then a heavy rake that you can almost barely pull up out of the water would be dense. And from 2016 to 2018, we had our water chestnut control project where we were primarily doing visual surveys looking for water chestnut, which floats on top of the water. But as we're doing those surveys, we also did rake tosses because we're already out there. We want to see what's in the water and see if there's any other high priority aquatic invasive species there. And so typically we just did recorded the presence or absence of certain species. And we also tried to give an estimate of the rake toss density as a whole, not for each individual species. So since these surveys were typically in water chestnut habitat, the habitats were mostly shallow water, mucky sediment, really calm areas, embayments, wetlandy areas. And so the species and the amount of plants that we found were typical of that type of habitat. After the water chestnut season in 2018, we switched gears to targeting hydrilla in our aquatic surveys. And so this turned into a more systematic point intercept sampling along different open water habitats along the lake edges. In 2018, our field team went around Cayuga Lake since there was known infestations of hydrilla there. Since then, we've also targeted water bodies that are nearby known infestations, as well as boat launches and marinas. In inclement weather, we'll sample around docks and shorelines. And then since I think 2018, we've also had our volunteer macrophyte survey program that is non-systematic sampling, where volunteers do a rake toss throughout the growing season in their water body of interest. And when we switched, as we've learned over the years, we're able to collect a little more data each time or each year. And so we started collecting, or trying to identify what the dominant species was on each rake toss. And we also learned that we need to give a different density to the floating plants as to the submerged plants. Since when you do a rake toss, it doesn't always catch all of the floating plants that you see in the area. And so I wanted to show where we were able to survey over the years. In 2016, we were able to do rake tosses in a wide variety, or a wide span across the region, primarily within the Great Lakes watershed. And these were all sites where we were surveying for water chestnut. Again, in 2017, by number, we didn't do quite as many rake tosses, but they were representative of the sites. We were able to get a good amount of rake tosses at these particular sites to be able to show what the aquatic community looked like. This is 2018. The yellow are the surveys or the rake tosses where we collected during the water chestnut program, and then the lime green shows the data that was collected during the hydrilla survey, including a private pond that was reported to have hydrilla our field team was able to go there and confirm. In 2019, we branched out to primarily focusing on boat launches and marinas within Cayuga Lake that was known to have hydrilla infestations. Seneca and Owasco, since they're nearby, Sodus Bay, Lake Ontario, and Bayments, since these are all connected to each other. And then as we can fit it into our schedule, we try to visit as many other high recreation areas as we can across the region. And same sampling design for 2020. We were able to hit a lot of the same sites as we were in 2019. Then we were able to visit a few more water bodies as well. And so this map has all of the years of rig tosses overlaid on top of each other, and you can see that we were able to cover several of the counties. They're sampled within several of the counties in our Finger Lakes Prism region and hit a lot of the bigger water bodies. Zoom toolbar is constantly in the way. All right. So since 2016, we've done almost 22,000 rake tosses in the region. We've been able to sample in 15 of the 17 counties, sampled 27 water bodies. That includes a couple of private ponds where we were confirming whether or not a species was there. We identified 48 species of macrophytes, and 9 of them were invasive. So in 2016, we were able to do 865 rake tosses. We didn't have a rake toss density estimate for all of them, but we did determine that 90% of the rake tosses had plants, or 10% came up empty. Here are the 7 invasive species that we identified along the way. And one thing I wanted to note was the graphs and maps that I'll show you are of the species that came up on rake tosses. So 2016 through 2018, since we were doing visual surveys for water chestnut, they didn't always show up on a rake toss. Similarly, we saw American lotus in 2016, not on a rake toss. It was an observation we made as we were surveying elsewhere. And 33 species of plants were identified in 2016. That includes a generic unknown pondweed, since the small-leaved plants are really hard to identify sometimes. Here are the 10 most frequently observed plants in 2016, with the most common being Eurasian water milfoil, which is invasive, but it was closely followed by the native coontail. And then there's a variety of pondweeds, water lily, eelgrass, duckweeds. And then the only other invasive that made our top 10 most frequently observed plants was water chestnut in 2016. In 2017, we weren't able to do quite as many rake tosses, but we had almost 300 across 8 water bodies. We saw the 7 invasive species that are pictured here and identified 36 species, including unknown pondweed. We were able to collect rake toss density estimates. And this is where I'll say that this seems typical of our wetlandy water chestnut habitats, where over 40% of our rake tosses came up with dense plants. And the surveys done during the water chestnut program were typically end of June through the end of August. And that's when it seems that our aquatic plants are most productive. So here are the 10 most frequently observed plants that we saw in 2017, coontail and water lily, bumping out Eurasian water milfoil. Then our duckweed, zelodia, and then the other invasive species was curly leaf pondweed that made our top 10. And again, we saw more water chestnut than is shown here, but it didn't show up on our rake toss survey portion of our data collection. So for the entire 2018 field season, we had about 2,500 rake tosses. So 706 of them were from the water chestnut portion of those surveys, and then 1,800 are from our hydrilla portion of those surveys. These were across 15 water bodies, including that private pond I mentioned earlier. And we identified 9 invasive species, and these are the 9 over all of the years that we've consistently identified. And the parrot feather was in that private pond that I mentioned as well. So we haven't seen it across other water bodies. And then in total, we identified 40 macrophytes in 2018. And I did break this apart by survey since we were targeting different areas. So 14 water bodies we surveyed for water chestnut, and those rake tosses show a little more of our 0 rake toss density. So we had some more rake tosses come up without plants, but a good chunk of them, are trace, sparse, medium, and dense, were pretty evenly distributed. And we still saw coontail and aladia and Eurasian water milfoil in our top 10, curly leaf pondweed as well. And then while we were surveying for hydrilla, this survey took place from September through December, through to the beginning of December. And so we're seeing a lot less plants on the rake. So much more 0 rake toss densities and more sparse and trace densities than medium or dense. And in 2018, we identified a new to us population of hydrilla on the east shore of Cayuga Lake, about 2/3 down at the southern end of Cayuga County, or southern end of Cayuga County. And at this point was the first time that in our top 10 species, we actually had no species become a top 10. With the most frequently observed being eelgrass. And then we also saw Eurasian water milfoil and starry stonewort. With a little bit of a new variety of native plants as well. In 2019, our surveys took place from June through October. And these were typically targeting the littoral open water habitat that we're familiar with, but primarily around boat launches and marinas. And so the rake toss densities stayed consistent for this type of habitat where we had a lot of rakes come up empty, but then there weren't very many plants coming up on the rake otherwise. We started collecting our floating plant data a little differently. So in 2019 and 2020, I'm only showing our submersed plant data. We did see water chestnut and American lotus, but it didn't come up on a rake toss. In 2019, another population of hydrilla was also detected in Tompkins County at the southern end of Cayuga Lake. But American eelgrass has remained in the top 10 most frequently observed plants during our hydrilla surveys, with Eurasian water milfoil and starry stonewort being the two main invasives that we see. In 2020, I showed similar data to our 2019 data. But I'm just impressed with the number of rake tosses our team was able to do last summer. 10,733 rake tosses across 15 water bodies. With American eelgrass still being our most frequently observed species, followed by Eurasian water milfoil and starry stonewort. And from our 2019 and 2020 rake tosses, since we targeted the same areas 2 years in a row, I wanted to try to pull out some of our data by month. And so you can see these are our rake toss densities by month for 2019 and 2020. We didn't have as many rake tosses in June. So I would expect this to potentially change once we get more data. But July through October and November, the darker green shows the denser rake tosses. So you can see we typically sample more plants in July, August, and September. It follows kind of a bell curve. There it goes. And yeah, we're out and we're looking for the aquatic invasive species, but I also wanted to note a couple other finds that were nice to see, including this one state endangered plant that we detected on Cayuga Lake called spiny naiad. And we've been identifying our native water milfoil that does hybridize with the Eurasian water milfoil. So, but I want to say we saw it more often in our 2020 field season than I'd ever seen it before. The main way to tell the difference between the native milfoil and Eurasian water milfoil are the leaves. When you pull the native out of the water, the leaves stay stiff. They stay like fluffy. They don't collapse along the stem like Eurasian water milfoil does. They also have fewer leaflets along the leaves, and it's more of a short and fat leaf than a long skinny leaf. And so for all the years, here are the locations where we identified Eurasian water milfoil. And I have a distribution map for each of the invasive species that we identified, with Eurasian water milfoil being the most widespread. I would say that curly-leaved pondweed is the next most widespread, although we typically see it earlier in the growing season, and then it dies back later in the summer. Starry stonewort, we've identified in several locations across the region. It is one of our high priority species for our area. I think it's very underreported, though. I think it's in a lot more places than we're aware of. Hard to identify, though. Brittle naiad. Again, not in as many locations. I think it doesn't grow in the dense populations that something like Eurasian water milfoil does. Frogba is primarily along Lake Ontario embayments, although we have seen it in the Seneca River and in Oneida Lake as well. American lotus, we've only identified at the north end of Cayuga Lake. Fanwort, we've only seen a couple plants kind of in the Onondaga Outlet, Seneca River area. During our rake toss sampling, we've identified hydrilla primarily within Cayuga Lake, but I did add these round red circles to approximately the areas where we know of hydrilla being, but they weren't sampled during this program. And here is the distribution map for water chestnut according to our rake tosses, but also wanted to provide a map of our visual surveys as well. I mentioned earlier, so we were able to systematically survey for aquatic invasive species during our water chestnut and hydrilla surveys. But there is additional sampling done through our volunteer program. In 2019, over 300 rake tosses were done. I think there were 42 people participating in it. 19 water bodies were sampled throughout that season, and those were across 13 counties in our region. And we were able to confirm the detections of curly-leaf pondweed, Eurasian water milfoil, and starry stonewort. And so there's a lot of little dots on this map. That's way more water bodies than we're able to visit in a typical season. So it's incredibly helpful having the volunteer program collecting data as well. So it's a little hard to see, but these bright blue spots are where curly-leaf pondweed was confirmed to be detected. We're able to confirm the volunteer data primarily based on photos. So a lot more rake tosses were done, but we were able to confirm these to have invasive species. Eurasian water milfoil, the blue spots are more widely distributed, and that lines up with where we had our other data collection, that Eurasian water milfoil appears to be pretty widespread across our region. And starry stonewort, not as much, but it is hard to identify. For our macrophyte survey program in 2020, we had 369 rake tosses in our region in New York, across 28 water bodies, 12 counties, 32 volunteers participated in the program. And so here are the bright blue spots where we were able to confirm via photos where curly-leaf pondweed was found. Eurasian water milfoil, again, more widespread. Starry stonewort. And I had one more and I forgot to put the text in, but here's brittle naiad again. Hard to see, but I think it's just in Keuka Lake and maybe the southern end of Canisius. Again, we haven't found this one to be in very dense populations. It seems to be a smaller plant. And so my big takeaway from looking at all of this data is that's a lot of water to cover. And so if anybody would like to join our macrophyte survey program, you'd be very welcome. You receive training and the equipment to do the sampling. And then feel free to keep up to date with our aquatic invasive survey efforts via Facebook, Instagram, Twitter, and the Finger Lakes Prism listserv. And that is all I have. So if there are any questions, I'd be happy to answer them.
Thank you so much, Kate. Can you please talk about the Otisco Lake water chestnut infestation?
Yeah. So we pulled there in 2016, 2018, I believe. The population had greatly decreased. I think we only had a handful of plants in 2018 when we last visited. It was mostly, I wonder if I have where the map is. Yeah, so this area was mostly just in Turtle Bay. And then there were a couple plants found. All right, this was a few years ago. Let's see. So in 2016, we only found water chestnut in Turtle Bay. In 2017, our partners there pulled water chestnut from the Narrows north of Turtle Bay as well. And when we visited again in 2018, we didn't find very much at all. So we were able to pull the entire population in the Narrows and in Turtle Bay that summer.
And I think we had a volunteer pull in 19, but not one in 20.
That sounds right, but I can't remember, unfortunately.
Yeah. So unfortunately, these populations will need monitoring for the next several years because like we've seen in Braddock Bay, just because we eradicated it in Turtle Bay, it doesn't mean that it didn't spread to other portions of Otisco Lake. So Kate, why do you think the frequency of Eurasian water milfoil and water chestnut findings have changed across years?
So I think we're targeting different habitat. And so we, in 2016, 17, and 18, where we were specifically surveying around water chestnut populations, it has mucky sediment, it's protected from wind and wave attack. So I think that's why those species were found in those areas. And then once we've moved out into more of an open water habitat, we've seen a change in the aquatic community.
Right, so the data from 16, 17, and 18 isn't going to be the same as 19, 20 necessarily, or 16,
right.
17. Right. Stephen, did you have a follow-up question or comment on that? He's asking if there's photographic documentation of each species collected, native versus non-native.
So we don't take a picture of every single rake toss. We do try to take representative pictures of what we're identifying each season. We do a pretty in-depth field training to begin each field season as well, so that we're pretty confident that the field team is identifying everything correctly, with the priority being the invasive species. And then any native plant identification is kind of a bonus, but.
Correct, and I think with the exception of the hybrid milfoil, milfoil, Eurasian water milfoil is quite easy to distinguish from the northern water milfoil and other plant species in general. So, you know, we do take quite an extensive training, and then Kate's out in the field with them for, you know, almost a month of training on hand to make sure that they're identified tight. We also do our trainings for the public that our crew participates in. So these folks are experts by the time they're done with us, and they usually want to stay on. So I guess that's a good sign.
We've accumulated a library of photos of these plants as well that we're able to reference.
Yeah, we probably have plant pictures from every lake that we've sampled and every water body. So just ask and we will have them. Does anyone else have a question on the sampling methodology or the water bodies that, you know, we've chosen based on our protocols, or just, you know, where we're moving forward next? So I'm not seeing any additional questions in the chat box. So Kate, I want to thank you. There is a question coming in. So there, can you talk about the water chestnut, the invasive water chestnut, and the usability medicinally or to eat? And is it used in Asian cuisine?
So it is not a water chestnut in Chinese food. That's a different one. That's a different plant species. However, in its native region, this water chestnut is used as a food source. I've never heard of anybody eating it around us, and I wouldn't particularly recommend it. I'm not quite sure what you would need to do in order to make sure that it wouldn't be harmful, so I wouldn't suggest collecting it to eat either. I'm not as familiar with any medicinal qualities it has, although I know I have read about it in years past. I'm not sure if there is anything else specific about water chestnut as a food source.
And can you talk about where it's native to and came here?
Yeah, so Eurasia, Europe and Asia. I've heard of it being a food source mostly in India, but I'm not an expert on that part of it.
So there was a comment that there was a recent report of water chestnut flour being a product. Another question that came in is, are we using a, go ahead. Are we using a stratified random sampling in regard to location, public access versus private, depth and habitat type?
So I won't say it's necessarily random. It's point intercept. We tried to, when we were doing rake tosses for the water chestnut project, we would try to do a rake toss every 100 meters at minimum. And those points really kind of depended on the shape of the water body we were in. So whether or not we were in a creek versus in one of the lakes. Then for the hydrilla surveys, it's pretty much anywhere we can get access. We try to survey on a 100-meter grid within a mile of that access, up to water depths of 25 feet per the Great Lakes Collaborative hydrilla risk assessment. That is listed to be the habitat that hydrilla could grow in. In areas where there are known populations of hydrilla, we do sample on a smaller grid, on a 25-meter square grid instead of 100. And so our radius around those launches is a bit smaller as well. Think about 400 meters. Does that answer that question?
Yeah, maybe you can talk a little bit more about your sampling plan in terms of where you choose to sample. Where are we choosing to sample primarily in these grids?
Yeah, so we're prioritizing Cayuga Lake because there are known hydrilla populations on that lake. And then by water bodies that are nearby, including Sodas Bay, Seneca Lake, and Owasco Lake, just due to their proximity. And then we're using watercraft steward data to determine which boat launches are busier in the region, and we try to sample those really high recreation, high use areas.
Great, so we're prioritizing boat launches and public and private access areas, since those are known to be areas where invasive species are spread and the greatest threat of spread. I hope that answers the question. So are we treating these areas for invasives and then finding more or less invasives, sampling the following year?
Yeah, so where we were able to physically control water chestnut, when we were able to control a site in consecutive years, we found a noticeable decrease in those populations. However, with water chestnut specifically, the seeds remain viable for 10, 12 years. So those sites will need more control and more monitoring. And then for hydrilla, that's a tricky one. The tubers remain viable for, I think, about 4 years in the sediment. Where we have treated hydrilla on Cayuga Lake, so there's, in one of the areas, we were able to dredge and then have an herbicide treatment, and we have not seen hydrilla regrow from that site. From another site where it was within a marina, so it's pretty much contained to the marina and not out into the lake. We've also had less hydrilla grow after those consecutive treatments. But again, that's a tricky one. So where we're able to do several treatments in a row or several control activities in consecutive years, we do see fewer of the invasive species, and natives. The native species tend to move in as well. So it's not being taken over necessarily by another invasive species.
Now the lakes that haven't been sampled thoroughly, are there plans in 2021 to get out there and do some survey there?
Yeah, so we still are prioritizing our the high use boat launches in the region, but for the lower, I hate to call them lower priority, but for the other sites, we'll probably try to rotate to get to water bodies that we might not have been able to get to in other years.
Great. Does anyone else have any questions for Kate on the sampling? So as a follow-up, our next Finger Lakes webinar will be looking at a history of the watercraft stewards in the Finger Lakes from 2012 to 2020. And so some of these sampling methodologies and reasons, the data that we're using to survey has been collected by our watercraft steward program since 2012. So we really try to use the science to push forth what our survey methods are moving forward. If you have any questions, we're going to put Kate's email address in the chat box. She has been Monacelli for about 6 months, but her email is still in her maiden name, which we'll be fixing soon. So don't get confused on that in that regard. So I want to thank everyone for participating, and if there are no further questions, we will end this webinar, and you can have a wonderful Tuesday, almost afternoon, And we look forward to hearing from you in regard to the macrophyte survey participation. We will be sending out a note out to the listserv shortly. So we welcome your participation there. Thank you.